Hi there. This is Tien-Yin Chou from Taiwan, and I'm the professor in the Huang University and the director of the GIS Research Center. Let me express my really welcome to all of you who joined this course with us together. And this course is organized by Taiwan Space Union. We say TSU. Taiwan Space Union is a nonprofit organization and funded by one of Professor Ye, and with all different university and enterprise and also the public sectors together. And we try to promote a lot of things regarding the space issue, GIS, remote sensing, and all navigation, and everything is all concerned with the space. So the Taiwan Space Union tried to organize this course directly from November 15th to December 27th, and for 7 continuously weeks, every weeks on almost each Wednesday's afternoon from 2 to 4 p.m. in Taiwan time. We try to have 1-2 hours courses organized by, I will be the first 3 courses, and my colleague, the Professor Huang, will be the 4th one, and also the Professor Huang will be the 5th one. And finally, one of my colleagues, the Mr. Chiu, will be the last one. So each of us will talk about different issue. For me, I'll start with the GIS remote sensing, some of the basic idea and philosophy, and some of the application implementation introduction to all of you. And then the next week, we'll talk about the smart city applications. And the 3rd one will be the smart transportation and logistic. And then the 4th one will be data analysis and data cubes. And the 5th one will be disaster management. And the last one will be the UAV and some of satellite images. So that organizes the 6 courses. Each one is 2 hours courses. And for the final one on the December 27th, we'll have a final project and also some presentation by all the participants. And then the Taiwan Space Union will organize and also give us a certificate of participation in the teaching. And also we'll have a very short quiz after each courses. So you need to answer those very simple questions if you pay attention to your courses. So hopefully all the courses will be able to assist all of you to join the world of the GIS and remote sensing, and also some of the GNSS and other kind of application which is concerned with the space issue. So let me start this afternoon's course first. My name is Tien-Yin Chou. Everyone call me Jimmy. I'm the director of the GIS Center in Huang University in Taiwan. And I also, as a president of the Taiwan Agriculture Information Technology Association. So I'm also the chair of the Open Geospatial Consortium, which is an international organization organized over the special issue, especially for the international standard. I'm currently serve as Asia Forum Chair. And I'm the Secretary General of the Asia Pacific Federation for Information Technology and Agriculture, which we call EPIFITA. EPIFITA organizes every year or every other year one big conference in different Asian countries. Next year will be hosted in Japan, in Japan near the Tokyo, the Tsukuba University will host the EPIFITA next November. So I got my PhD in the Michigan State University by the Department of Resource Development, and also my master and my bachelor degree from National Zhongshan University in Taiwan, from Department of Soil and Water Conservation. So I have some background on the soil, on the water, on the physics, on the biology, and also got resource development PhD. So I learned the GIS, remote sensing, during my different study period. So hopefully I can introduce some of the GIS basic information and some of the remote sensing and to all of you. So let me make sure everyone can see this screen now. Spatial Information System application by the GIS remote sensing. Okay. So for any kind of geospatial process, when we say the process, we mean we need to capture the kind of information, because for the entire environment is a very complicated system. So we need to record every very good signal or every good phenomenon. And we need some kind of way to take everything into digitized format. And the way into the digitized format, the most easy way to make a map. And how can we make a map? We need a coordinate system, and we need to know exactly the positioning. And we need a mapping standard and some of good platform. And we need some kind of sensor technologies, like the different kind of surveying equipment, like the GPS or some other different kind of surveying equipment. Or now we can use UAV, we can use a lot of things. And also, we need to have some kind of model to processing the techniques and modeling all the techniques and data standards and data formats, and make a very good resolution and different kind of level detail. As we say, the level detail is like level detail 1 or 2 or 3 or even 0. So then we can really manage the data. So using some kind of database management, then we can have very good management of data. But we need to emphasize about the data exchange standards. And to the finally, we can deliver the entire map with the attribute data for not only the maps, but also can have people to visualize that one. So now the map, or we say geodata services, is one of the very good solution to the entire world. So what is Geographic Information Systems? As we say, the GIS. So the GIS, as my definition or some definition by wikis, is integration of relevant spatial data. And when we say the spatial data, means the spatial data with the attribute data. So it's established on the foundation of geographic database. So this kind of database is not only the map, but also what inside the map, what's meaning by the map. So all the information is enabled. We can use that to extract, to edit, update, to data saving, to inquiry, process, analysis, and display. I think that's the most powerful use of the GIS. So that's the wiki's definition of the GIS. So if really use a map, we can see this is a spatial data. As we can see, these are all the maps with a boundary, with some different kind of like river or some other information. And also we have the attribute data. Attribute data means for each information, we need some kind of data to describe the information. For example, what means by a boundary? What means by the area? What means by the road? What's the road type name? All this kind of information, if we use the GIS spatial data and attribute data, then we'll be able to organize the entire information. So the formation of the GIS, we need hardware, of course, because we need hardware, we need those kind of chips and those kind of tools for the GIS to display. Doesn't matter if you use any kind of different software like operating systems, if you use open source or very simple embedded coding technology, or some very good commercialized software. And also we need data, and the data means by the maps itself and also by the attribute. And for the GIS, the good thing of the GIS is most of GIS will not be able to accomplish only by one person, because everyone has a limited time and energy and expertise. But for the GIS, because we can do the integration, so emphasizing the integration and also the interoperability. The interoperability means the changes and the sharing of those data sets. It means the attribute data we can share, the attribute, the maps we can share. And also we need a good model or algorithm to modify the entire things. So that's require the system operations and the rules. So where comes all the different kind of sources of all the data? All the data sources come from above us. There are satellites. There are several thousands of satellites, especially during the past probably 3 to 5 years. There were thousands of the low altitude, low orbit satellite being launched, especially for the communication. And we have resources satellite, we have weather satellite, we have lots of different kind of navigation satellite. Lots of those kind of satellite provide all the information to us, or some kind of aircraft, like the aircraft, like some of the airplane, or the drones, the UAV, or different kind of sensors. Even you can use your cell phone as one of sensors. You can use different kind of rain gauge. You can use different kind of noise receiver. You can use lots of things. You can use your camera. You can use lots of things as one of the sensors. All this kind of information is one of the data sources. So there are thousands or gigabytes of the data every day surrounding us. But how can we use all the good data sets to emphasize and also to describe the entire world? If you're looking at this kind of graph, you'll notice the graph represents a kind of three-dimensional issue for the surface and also for the land cover, or you can identify as a land use. And even you will be able to analyze the slope, aspect, political boundary, or any kind of implementation of any kind of like watershed management or some other issues. So there are lots of information will be able to expressed by this kind of information. And before, when all the software and hardware were not this kind of high tech, we need a lot of energy, even the budget to spend to build this kind of information. But nowadays, we can just use our cell phone or just use some image hit by the drones or some very simple satellite images. Then we'll be able to organize this kind of information to represent our world. So everything becomes much easier now. So when we say the content of the GIS, as I mentioned about, I always mention two things. There are two kinds of data sets. One is the spatial data. One is attribute data. When we say the spatial data, just like what you have seen just in the previous one, it describes the terrain, the surface changes, location, spatial relative location by the point or node or line or arc or polyline or polygon or area or region or surface, or even now into a 3D world. Before we say maps, but now as we are looking at our entire environment, even I'm looking at just a flat screen, but I can still see a lot of three-dimensional issues. So that's all we call the spatial data. And the most important one is we need attribute data, which means the text or the numbers and recording the geographic elements either way, in nominal way, ordinal way, or interval ratio scale. Those kind of scale is to assist us to describe what's inside this area or this point or this line. So that means the attribute data. So if we say the GIS, then we say the GIS generated map from the ordinary map data means we need some kind of projection, then we need coordinates, and we have to say what's the scale of that. So we need to know what kind of projection you're using for your map. What's the system of the coordinates? And what is the scale? Like 1 to 1,000, or 1 to 5,000, or 1 to 25,000. So it's all different kind of resolution, different kind of information can be represented by either the GIS maps. Let's look at this map. This is one of the map for where I live now. I live in the Taichung city. So this is a map of the Taichung city. This map is one of the very basic map. There's a control point, coordinate, scale, and map orientations. Like this is a map orientation, and this is some of the special area locates, and this is some of very, very important road construction inside the city, and also with the political boundary. So all these kind of things describe, this is the boundary, this is the road, this is industrial area. It means the numerical factors. And what's the geographic factors? That's the nature or the social or economics factors, like residential area, the transportation, the network, the water systems, the terrain, the vegetation, or the border. All these kind are geographic factors. So like this one, we have the map, and basic from the map, we have the attribute data to describe what's inside the map. What means by this point? What means by the line? What's meant by the area or the region or the boundary? What means by the different color? So different color means the park, or the different color means the industrial area. Different color means the university. So all this kind of information is a very basic one to describe a map. And also there are lots of different things, such as the charts, the slope, the scale, the diagram, the unit, editing date, and some other information. It all organizes the entire map. So we say the map is numerical factors, geographic factors, and other factors. With all these kind of factors, it describes the entire map. This is one of the very basic application of the GIS. If we say GIS, it means I have a different layer of map. So if I draw this boundary on the map, I'll be able to display different kind of land ownership. So different color means different kind of land ownership. So this is a very basic geographic map. But once I use my mouth to draw the boundary, then it shows a different kind of color. It means different land ownership boundary, like either from the public one or the private one. And either from the private one, let me get some more detailed information. So this is a very basic, we say the GIS application by the map and by the attribute data. If you only have the map, you can only draw the boundary and that's it. But also we have the attribute data, so I know exactly inside this boundary who owns how many area, how many lands inside this boundary. So because I need the answer of the entire area, who own those land and who are the ownership and what's their land size or the land area. All this kind of information, I just use the GIS and very easily to extract all the information directly from the map. So that's the use of the map. So we say the GIS, or even for we say the most common one is the Google Earth, is very, very simple or easy. We say the GIS, or with some satellite image or some airfoil information. And it describes, this is a map of the Taiwan and the surrounding area, like the Pacific Ocean and the Taiwan Strait. And this orange color means the boundary of the Taichung city. And I can just go through and go inside a very detailed one to check each land parcel ownership. And I can overlay with different kind of maps. I've been overlaid with satellite image, with aerial photo, with land parcel, with land ownership, lots of road information, transportation information, lots of this kind of information. So I can use a very basic GIS application to identify either the land parcel I need to find or some of the analysis. For example, this is a Salmon Lake. Or for example, this is one of the ocean site in the eastern border. So I can check, I can browse entire information, use a very common Google Earth. But because the Google Earth is following one of the Open Geospatial Consortium standards, so I can also just feed in my data sets and use the Google Earth as my platform. So I can use my own land parcel information. I can use my own aerial photo information. And inside the Google Earth, I can retrieve and also analysis all the information directly. So I use a lot of like overlay. I use a lot of integration. So that's why I'm saying GIS is a very, very good tool or function or a kind of systems, because you need for integration, you need for interoperability, you need to have some kind of sharing, because every kind of data sets is created by different organization, different person in different year, or even different kind of technology. But if I want to overlay everything together, I have to follow international standard, and I have to follow the entire GIS standard. So that means the maps and also the attribute data. So let me start to talk about one of the very basic information, organize the map, the spatial information, the projections and coordinate systems. I think that's the lesson one as the map. Why we need to learn about the projection? Because the world is not a flat one. And also, as we say, Fengjia University is located in the number 100, the Wenhua Road in Taichung. But how can a computer locate where the Fengjia University is? If we need the computer to locate where the Fengjia University is, it has to identify where is Taichung, then where is Wenhua Road, then where is 100 of the Wenhua Road. So that's a very complicated thing. But for projection and coordination means Fengjia University locates at 24 degree and 10 and 43.5 north, and 120 degree and 33 and 48.3 east. So that's a coordinate. So if we say that converting the Earth into standard ellipsoid generates the coordinate, that every location has a unique coordinate, has a very unique one. We can use the coordinate to represent that. But as I say, if we say the map is a flat one. Even nowadays, we can use the three-dimensional to describe it, but still, we are used to see the maps as a flat one. So we need the geodetic datum. Why we need that one? Because each north or east one, we need some way to represent the same kind of scale. Then we need the geodetic coordinate systems. So that's why we say the geodetic datum. The reference for geodetic coordinate system in different study areas, different GeoID. And so then most suitable region or global geodetic datum. So there's no one solution for the entire world. Each country has its own geodetic coordinate system. Like in Taiwan, because Taiwan is a very narrow one. There's only 2 degrees. So Taiwan use the different kind of geodetic datum compared with the other part in the world. So GeoID is a shared with equal gravity and the mass of the Earth acting as a center. But the entire world, the Earth we live in, is not a completely perfect sheer round. It's not. It's not. So when we say the center, it's different kind of the calculation will give different kind of or different location of the center, because it's irregular surface and usually using the average sea level as the GeoID. So very common we say average sea level 0, but even for the average sea level, it still change every day, change different month. So summary should use the most suitable ellipsoid ID as the GeoID. So it's very complicated. Like in the world, we say there's a north, there's a south, there's a meridian, there's a equator. So when we use the north or south or east or west, we use the meridian and equator to represent where it is in the entire Earth or the global of Earth. So this is to the east, this is to the west. So in the world, many years ago, those very smart scientists, they try to identify if we can have a good way to describe where it is and using an X and Y way, then that will be much easier. So they try to find the best way for the projection. So that's why, as we mentioned about, we say the projection is one of very important thing for GeoID. Because different kind of projection give us different kind of map. So the purpose of map projection is map observation and terrestrial globe. And terrestrial globe is bumpy with the low mobility. As we can see, if we use this kind of map, we use the straight line as the equator. And we use this kind of line as a meridian. So it's all different. It's different latitude, attitude, and each size of this kind of size rectangle is not a rectangular. It's not perfect rectangular, but it looks like very similar as what is. So how can we make like the globe of the Earth into just one map? That's why we need a projection, because we have to have a way to really flatten the terrestrial globe. So that's the way. And there's several different kind of projection types. The conic one, the cylindrical one, the azimuthal one. So as we can say, this is the most common way. And also use this one or use this one. It's all different. So if we put the Earth inside and then we use the conic one, or the kind of oblique conic one, or the transverse conic one, or we use the cylindrical, the projection, or we oblique or transverse one, or we use the azimuthal one, or the oblique one, or the transverse one. So it will all show different kind of map, because if we use a map to surround the Earth using this one, then when we open that, it's different. It looks entirely different. Or we use this one, it looks entirely different. So map scale is the same as actual situation. If we use this one, if we use this one, but this one once we can only show half of the world. If we put the light on the south, we can only see the north. We only see the north, so because the light is so far away in the south. So you can only see the north. But even we can see the north because it's just projection. It's a project like here. So just like this one. It's a projection one. So it's still, everything looks different because near the equator, this is near the equator, the things become very, very strange. It's really, really a very big one, then a small one, but it looks like very, very similar as the original size. So the azimuthal projection can be divided into the orthographic projection or central projection according to the light source. So if we put the light source very, very far away, it looks like the orthographic projection because the light is from the infinity. It looks like just here is here, 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 here's here. So if we put the light source as a very infinity one, then it looks like an ortho one. It looks like an ortho one. So there are several ways to put different kind of map because of the projection, because of the light source. If you put the light inside the Earth, then it looks like this one. Or we put the light just in one side of the Earth, it looks like this one. So it's completely different. So if we put the light in here, it can all map the world, but entire world looks completely different because it's a flat one. So that's why there are so many different kind of projection. In the world, the most common one, the conical projection, the latitude and longitude, you'll be able to display. And each one is parallel to each one. So this is the good side, but the disadvantage is the area near the poles will be magnified. So that's why if we see this kind of map, then near the poles will be completely different. The North Pole or the South Pole is not like this large, but most often we see the world map look like this because it's used the conical projection. So the North, in fact, in the really global Earth, it's only one point, but here is the entire size, because you use this one. So it's entire size, as the North, entire size, as the South is the same as the equator. So all the sizes are the same because this is the projection we use. So there are pros, there are cons for each kind. Conical projection, it's the same way. The area is more accuracy near the tip of the cone, just like the ice cream. We put ice cream in the globe of our Earth and put the light over there. But the conical projection leads to area distortion, just like this, just like a fan, just like the fan. For the entire world, it will look like this one. So still, it's not the real world. So it's not the real world still. So there are always the pro and the con for each kind of projection. So if we can unfolding the maps with the projection, for example, like the North or the South, then we can use this one. Like the other place, we can use this one. But if we want to see exactly how it looks like, we can use this one. So there are lots of different kind of projection, depend on how you can describe the world. How you can describe the world. Just use a kind of two-dimensional issue. So that's an important thing as we mentioned about the maps, we need some kind of projection as the very beginning. So in the world, the most common one is a universal transverse Mercator. There's one physics scientist, the Mercator. He discovered the way of the Mercator cylinders. So in the world, there's a universal transverse Mercator. What I mean by transverse Mercator means this kind of cylinder one, we can put it not in the north to south, but on the other way, like this one. So transverse Mercator is this one, transverse one, the cylindrical transverse one. So the Mercator discovered this is a very good way to describe the entire world. So for the entire world, the latitude, every 6 degrees is one of the zone. So for the entire global, there's 60 zones. There's 60 zones. There's 60 zones. 60 zones represent each one, and each one we can use X and Y to represent what's X, what is Y. So that's how we say it's universal transverse Mercator systems. So it's every 6 degrees, then we have one rectangular area, and we can describe it as a world map. And so this is one of very, very common, when you see the world map, this is very common one. We say UTN zone maps. So that's mean by the projection. So you need to know, because of different kind of projection, different kind of GeoID, different kind of light sources, you must have a different way to represent where you are. Not only the X or Y, but also the area. Because if you try to identify the size of the map directly and also represent the real land size in the world, then you have to use a very common used GeoID and geodetic system in your country. Each country developed its own geodetic data. Like in Taiwan, as I mentioned about, because Taiwan is located at here. So if we use the UTN 6 degree, then it will be too wide for us. So in Taiwan, we use transverse Mercator 2 degree. So in Taiwan, the longitude 120 to longitude 122, that's the Taiwan island. And we use transverse Mercator 2 degree to represent how we map the Taiwan. So it's different kind of map. So you have to know what is your geodetic data in your country. Each country depends on its size and also depend on its own standards. You might have your own map projection way. The reason for that is because in the real world, it's really complicated information. Because if we try to describe what is on the surface, what is this building, what's the kind of land use, what kind of forest it is, what kind of land cover it is, we need to have so many different kinds of data sets to describe the entire world. So not only projection or the ID, but also we need to identify what the point is, what the line is, what the area is, what's represent this rectangular, what's represent in this pixel. So there are two ways to represent the GIS data sets. One is use the vector one, means we use the point, the line, the polygon. Another one is you use the raster one. Raster one just like the photos we're looking at, just like the satellite image we're looking at, just like the drones image we're looking at. So use the vector information or raster information. That's the most common one. For example, the vector one, just like the common maps in the world. So if you look at the world map, is mostly a vector one. Then what's the image one? Or we say the raster one, or someone says grid, or it's pixel. There are so many words to describe. That's an aerial photo. That's a satellite. That's a drone image. That's an image. That's a raster. So the vector and raster is two ways to represent the entire spatial information. So vector information including the points, the lines, the polygon, and the raster information or the grid or the pixel. Means if it's point, depend on what the size of your grid, what's your pixel size. And the lines also to connect each point, means each grid or each pixel, they represent a line. And polygon means different kind of grid get together, then it's mean the polygon. So there are two ways to represent everything. Point, line, polygon, use the vector, or the point, line, polygon, use the raster, or the grid, or the pixel information. So there are two ways to represent the spatial information. So for the vector format, as we say, the point, the line, and the polygon, or the area. So the point, it might say, okay, by the nominal data, this is one of the house, or one of the department store, or one of the university. Then that's the nominal scale. The ordinal scale means this one means this point can have some kind of agricultural yield production of 100 tons. Or this one means 500 tons. And this one means the population density, each point is 100 people. So that's the density. That's all points. But that's nominal data, that's ordinal data, that's interval ratio data. If we use the line, it's the same thing. For example, this is Wenxing Road, this is Zhonggang Road, this is some other road. And let's describe the entire thing. Use the area, that's the west side, that's the east side, some kind of political boundary. This is Taichung City, this is Taipei City. Then that's the area, use the nominal data to describe it. Or the ordinal data, it means the city level of the roads. It means the country level of the road, or the state road, or the interstate road. And if you're looking at different kind of contour line, like this is a contour line, 100, 200, 300 means the elevation. That's also use the line to represent interval ratio. And use the area, it's the same thing. The major developer area or the minor developer area. Or we say this one means the area has a population higher than 2,000. And this one means between 150, 100 to 2,000. This one is below 1,500. So their point, their line, their vector, and use the nominal and ordinal interval ratio to represent the entire spatial information. And that's how we say it's a vector format. It's a vector format to represent the entire thing, like use the point, or use the line, or use the area. So let's look at how we can put into the computer. By each point, by point with point, organize a line. And using the line, organize the polygon. So that's how we make the vector data information and how we can digitize into the computer. We can have the kind of point represent a nominal one, like this is one of the university locates at. or this is one of the major industrial area developed, and this is one of the major state road. This is another state road, whatever. So we can use the point, the line, the area to represent the entire spatial information. And in the GIS, in the vector information, there are different kind of words to describe. There are points, there are nodes, there are vertex. So vertex means in each vertex, it's a changing the direction way. And the node is every line, everything when it's intercept, then that's a node, or starting point or ending point. Starting point, ending point, intercepting point, that's the node. So for the polygon, there is only one node because it's a starting point and also it's an ending point. And as a point or as a node represent a department or one of the POI, then that's also a node. So a node is a starting or ending or intercept. So for the DTM things, if we're looking at the more complicated one, so we use the vector grid one. So it's a point-to-point relationship in a grid by the metric one. So we can say this is the grid. But if we try to represent the aspect and the slope, then we'll have another information. We need to have the elevation of each point. After that one, we can use the Tien model, the irregular model, to describe the entire point by this way. So each Tien means one of the homogeneous aspect and slope. So this means one homogeneous aspect and slope. So that's mean one Tien. That's another Tien. That's another Tien. That's another. So everything is a triangle one. It's a irregular description of the points. Each triangle represents a polygon. So this way we can describe the terrain. So this is how we can make it from a two-dimensional way to three-dimensional way to represent the entire world or the slope or everything. So that's a grid or that's a vector one. And if you mention about the remote sensing, there are lots of different kinds of remote sensing. What is remote sensing? The remote sensing is if you measure something of the object characteristic without direct contact, which means you don't really touch it, but you can sense it and you can record it. And you can tell by the different information. So there are lots of different kinds of devices in the daily life, even our cell phone. We say the remote sensing devices, like X-ray, whatever. There's so many things. There's telescope, so many things as a remote sensing devices. And how those kind of remote sensing devices can capture some of the information without really touch it. It use spectrum. The most common way is to use a spectrum. The spectrum is one of the energy represents all the energies in the world, of the Earth, the energy from the sun. It's a wavelength. So all the energy, there is a very short wave, there is a very, very long wave. And the short wave, the short wave from the gamma, from the X, or from the ultraviolet into the visible one. The visible one, and we can say is directly from the blue, the green, the yellow, and the red one. And then the long wave one, like the near infrared, or the red one, the microwave, or some of the other one. That's all the long wave, like television or lots of like the radio, those kind of long wave one. So people can only identify, use our own vision or our own eye, is this kind of visible spectrum wavelengths. And that's it. All the other wavelengths will not be able to identify by our own eyes. We have to use some other device. So the advantage of the remote sensing is it can obtain a very large area information in a relatively short period of time, such as satellites, such as UAV. Information can be displayed in form of the geographic or non-geographic messages, reduce the manpower and risk of operation. So the good thing of remote sensing is we can get very, very detailed information very quickly. So air photo, satellite image are the common types of remote sensing images. And nowadays we can use the drones also. So there are lots of different kinds of remote sensing information. Not only the satellite, the drones, the aero photo, lots of, like the aero photo. So the aero photo, it can create a lot of orthophoto images to represent the entire land surfaces. So with the airplane carry a good camera, so it can create a very high image quality and very high spatial resolution, very high scale images. But the disadvantage is easily affected by weather. If the weather is not good, then the visible is not good, or there's too windy or even a cloudy day. For example, like in Taiwan, quite often we have typhoon during the summer season. Quite often we have clouds with bad weather, or even for the high air pollution. So lots of times non-real-time images, because it's hard to get all this kind of preparation and get all this kind of information to be corrected. But this is one of very, very common information identified as one of remote sensing technologies. So that's also one of that one. If you look at one of the aero photo, for example, this one. This is a very simple aero photo in one of the county in Taiwan. It represents some of the very high developed urban area and some of the rural area and most of the agriculture production area and the major road construction and some of irrigation infrastructure. All those kind of information you'll be able to identify directly from the maps. So that would be a very good source for us to understand what the environment is currently. And this is another places in Tainan by the aero photo. And using the aero photo in Taiwan, the government used the real aero photo to organize the entire ortho map of the entire Taiwan. So in Taiwan, we have very, very complicated geodatabase of using all this kind of aero photo and produce the orthophoto images for the entire Taiwan area in different map scale. So there are lots of this kind of information is available. Not only the satellite information, but also the aero photo or some of the UAV informations, which is very useful nowadays. Okay, so I think I started the course for about 50 to 55 minutes. Let's take a short break. For those of you who have any question or need some more information, you can leave your words on the communication area, and our colleague will try to answer for those kind of questions. So let's take a short break. Let's come back probably after 10 minutes. So thank you. Okay. For every of you, I hope you're listening this course are correctly. My name is Tien-Yin Chou. I'm the professor and director of the GIS Research Center in the Fengyang University. This course is organized by the Taiwan Space Union as a continuous course for 6 times. Each slot is about 2 hours in every Wednesdays afternoon from 2 p.m. to 4 p.m. in Taiwan time. Hopefully you'll be enjoying this course with me and some of my colleagues. And we hope this kind of GIS promotion course will be able to promote some of the very high technique as a GIS or remote sensing and some other application regarding the space issue can be very widely spread out in the Asia area, and also will be a very, very useful material for each of you who try to understand the basic idea of the GIS. As the previous one I mentioned about, the GIS can be represented by the vector information or the raster information. And also we need to identify what kind of projection, what kind of geo-ID, what kind of geodatum we have in our own country. And we know exactly how we can make the point, the line, the polygon, use different kind of spatial information, attribute information to describe what is inside of that. So let me continuously talk about the aerial photos in Taiwan. In Taiwan, the government regularly organize different kind of aerial photo images operation for the entire island. But because some of the very high mountain areas, because of weather concern, so mostly it's very hard to get a very good aerial photo. So we can use the remote sensing image to represent some of the photos and some of very good one. And if we look at the different kind of photos like this one, this is a different resolution. So the resolution really matters. If you look at the 50 centimeter resolution of any kind of aerial photo or satellite image, or we compare with the 25 centimeters one, we can see a lot of things. So the record of city development is one of very good application for all the aerial photo or the satellite image or any other things. So for example, like this is Taichung City in 2000. And then just after 10 years, you can see there are so many high-rise building inside the entire area. So that's only the 10 years changes, and it's all by the aerial photo. So as you can see, that's a 10 years period, and it's all been changed. So inside the 10 years, there are lots of things being developed, There are so many different places in the Taichung area just in the 10 years. So we can use the aerial photo to represent the different kind of land use, different kind of land cover, or different kind of land shape very easily. Let's look at these two graphs. If you can identify what's on the left-hand side and what's on the right-hand side, can you tell the difference? If you look at, this is one of the aerial photo, this is another one of the aerial photo. And this kind of aerial photo, we use that to describe the entire vector information of the road, of the house, identify each building, everything. But use this kind of information because during the daytime, when the entire environment is visible, there are always traffic on the road, just like this one. But when we create the map, we would like a clean road, which means there's no vehicle. But how can we do that? So before, we have to delete or move out each vehicle by human effort. And it's really hard job. But now, because of the artificial intelligence, because of the machine learning, we can let the software identify and knowing what looks like the vehicle on the road, and can you move the vehicle out and still use the possible something under the vehicle. So you need to get the entire shape exactly as what it should be on the road without the vehicle. So now the machine learning, or we say the artificial intelligence, will be able to do these kind of things very easily or very directly. So it can do the kind of deleting the vehicle from the aerial photo, a very quick one, just like this one. So you see there are so many vehicles on the road, but this one, there's none of the vehicle on the road. And the artificial intelligence, it will automatically use the possible things under the vehicle and gets it back. Sometimes still not correct, but most of times it is correct. Because it can learn. And also, once it learned about this one, and we say, okay, you did a perfect job. Next time, when there's a new aerial photo, he will know exactly what should be here because he know he did a good job last time. So that's the advantage of the machine learning, or we say the AI. And that's the way for current technology has become a very useful one, just like this one. There's so many vehicles on the road, and we can just use the same kind of AI to the machine learning technology to eliminate all the vehicle directory. So this is very useful technology. Like before, if we really try to identify what is on the road without all the vehicle, it's really hard, and we need to do a lot of human effort in. But now we can just do that very simple, very easy, very simple one. Just as this one. We can take all the vehicle out, but still like this one. It will automatically think about, okay, this should be under the vehicle. So this should be the information, like this one. Because it learned by the other one. It learned by the other way. It learned by the other way. So you say, okay, it should be here. It should be like this one. So we say the machine learning, or we say the most artificial intelligent one has increased a lot of the current power of us to get the real information. Let's look at another remote sensing technique. That's the satellite images. That's the satellite images. There's so many satellites. There's so many satellites orbiting the Earth. There are navigation satellite, there are weather satellite, there are resource satellite, the communication satellite, or even there's spy satellite. There are just so many and more on the way. Like now there's almost a million satellite now. So it's between probably 7,000 to 9,000 satellite. But to the next probably 2 to 3 years, there'll be over 1 million satellite orbiting the Earth. So there's so many satellites orbiting the Earth. Each satellite has its different functions in different orbits. Some of satellite very close to the Earth. It can orbit the Earth. It has to orbit the Earth really fast, really fast. Some of the satellite is far away from the Earth, so but it still needs so it's go just like how the Earth is going. So we say this kind of satellite is always face the entire places of the Earth, just like some of the weather satellite. So it just go around the Earth movement. And so it just go around the Earth's movement, so it can always catch the exactly the same places of the Earth, but it's a very far away one. So when you're near one, you have to rotate. Otherwise, the gravity will get you inside the Earth. So depend on the function of the satellite and depend on the orbits on the space. So every satellite has different function. For example, the most common one, the SPA from French. The SPA satellite is one of the very, very common satellite we use, even in Taiwan now. And for example, the SPA, it has different kind of band. It has a green and red infrared. So using that one, we will be able to identify the water compared with the vegetation, or the vegetation compared with the non-vegetation, or some of the transportation, or some other ways. It's very easy to compare with the bare land, with the forest, or with the water itself. So it's very easy to display that because it has an infrared. So satellite image, there are lots of different kind of application of those kind of satellite images. And sometimes it's really hard to identify with the satellite image with the aerial images. But one thing you can say is aerial image is more close as what the vision, our eyes can look at. But for the satellite images, because some of satellite, yeah, because someone, yeah, okay, thank you. The satellite image, then since it has a near infrared or infrared, then it can represent different kind of the composition, which is not in the visible spectrum one. So we'll be able to identify the vegetation with the non-vegetation, or the water with the vegetation, or some other different kind of land cover very easily. And nowadays, the UAV is one of the very, very good way, because nowadays the UAV with Internet of Things, artificial intelligence, surface platform, and also a lot of things. Like most of the commercial drones are equipped with a visible light camera, and take a look of photos and link them together for the service platform as a service platform. So different camera, different sensors, different UAV, it all has different purpose. As we say, the smart city, then which means all the information will be able to capture with the satellite image or the drones or the aerial photo. We'll be able to use a lot of different kind of remote sensed or remote sensing information. So most of the UAV can carry the payloads, depend on the weight varies. And some UAV can have the fixed one, some interchangeable equipment, and different tools for different purpose. So like some UAV can capture the images, some UAV can capture some of the thermal information, or some of the other information which is not visible spectrum one, which is not like human eye will be able to capture one. So those kind of UAV can be very useful. So common UAV mounted sensor like the RGB, that's the most common used UAV for the camera, most common one. And for the images or the video or even the night or screaming video, or the thermal one. The thermal one will be able to identify in the near infrared. And you can identify lots of things, use different kind of spectrum. So the UAV will be also to create lots of information which is either visible one or non-visible one. Receive the thermal signal and non-destructive inspection, or NDVI. So even now, there are lots of small medium enterprise company that can produce very good UAV to make different purpose, even in the show business now, or lots of different kind of, even for disaster rescue, or even for spy, or even for lots of the other use of the UAV for the defense. So there's so many different kind of use of the UAV nowadays, depending on what kind of payload you're mounted on your UAV and what's the purpose of your UAV. Like the NDVI cameras, it can very easily identify near infrared with the red. And also mesh together, it can identify if it's agriculture or not. And different light spectra detect the plant health. If there's any kind of plant disease or any kind of some other infected, then use the NDVI camera is very easily. But it still needs some kind of analytical knowledge to identify if the NDVI become the figure becomes smaller or figure become larger, means what kind of illness or what kind of disease of the plant. So still require a lot of different kind of analytical knowledges on the back. So there are lots of this kind of UAV nowadays. For example, the visible light camera, it can represent the UAV. Like this one is a very beautiful ocean side in Taiwan. It's a very beautiful one, and it's very common to capture that this like in Taiwan. So using a UAV is a quite useful way for us nowadays, because the UAV is one of the very good source nowadays. Like before, we can use aerophoto or the satellite images or some other ways, but now we can use the UAV. A UAV, aerophoto, satellite, it all has the grid information, or we say the raster information. But we will need to identify what this means. It means a very clear ocean water. What this means? It means a rock. What this means? It means something else. So then we say the attribute data. Because from the raster images, each pixel or each grid or each or we say just each size, then it represents different kind of spectrum reflectance. So let us see this different kind of color. But for the attribute data, we need to identify what it is. So that's the good way for the graph information combined together with the attribute data information. So the application with the visible light camera is aerial survey or mapping for the orthophoto now. Like before, 10 years ago, you cannot use a UAV for orthophoto production because it cannot fit the required standards. But now all the rules have been changed. Like in Taiwan, the surveying rule, we can use a UAV for the very formal surveying now. We can create a different scale of the map. Just use the UAV. It's impossible before, but nowadays, the UAV can use very wisely now. So it's a fixed flying, attitude and speed. A fixed attitude and speed, sense scale, and constant overlapping the rate. So it's very similar as the aerial photo before, because it can make a very constantly and very fixed attitude and the speed, just like required for the large aircraft before to make a very good aerial photos. So now UAV can replace the original, the big airplane aerial photos, but still depend on the scale. If you're looking at the entire country wide, you have to use aerial photo. You have to use big airplane. Otherwise, UAV, you have to use hundreds or thousands. So there's still some kind of limitation, and there's still some pros and cons for each application. But the technology, the basic information are the same. It's the same thing. It has to be overlapping, then to create the ortho photo. And use the ortho photo, we'll be able to know exact location, and we can create, by the raster information, create the vector information, create the attribute information, and create a very good GIS information. So it's the same thing as the overlapping, like 70 to 90%, then we can use also photo creating. So combining photo by common ground features, then it's very common used nowadays, even in Taiwan or in many parts of the world. the UAV can really replace a lot of previous the big airplane can do, like the UAV for mapping. Like before, we still need to have very good the ground control point surveying, and now with the UAV and use the RTK, we can have the real-time kinetics positioning, which means the RTK can send a signal back directly and get a differential information directly. For example, in Taiwan, the government has a kind of service we say eGPS. The government has already set up a lot of GPS receiver stations in the entire Taiwan, lots of places. So each surveying company, they only need to pay a very few amount of money, a rental money, to rent the service by the government to produce the eGPS, or we say eGNSS, because it's not only the GPS satellite, but also the GLONASS from Russia before, the Galileo from the European, the Beidou from China, and the GPS from the US, and some other positioning satellite now available in the world or to the world. So there is also a service called eGNSS. It sends a differential information directly through certain kind of communication to any kind of surveying equipment, even UAV, even your cell phone, even whatever. And you can get a very accurate positioning directly. Like now, you can get almost like centimeter scale of the correction. So use just a very simple camera or use your own cell phone. You'll be able to receive the eGNSS services and use your own GPS or GNSS receiver. You'll be able to get a centimeter accuracy position. So that will change a lot of things. That will change a lot of things now, because the technology nowadays is being developed so quick. So there are lots of things for disaster investigation. Like once we create also photo, we can create a digital service model, as a digital service model, digital terrain model. So we can calculate the land size volume, the affected area, the precise position of the landslide. So all this kind of information will be very easily to be created by the UAV or by the aerophoto to create the orthophoto. So this kind of application, this kind of uses nowadays in Taiwan has been very widespread out. So it's very useful. It's very useful technique nowadays in Taiwan. So there are lots of companies, they own their own UAV, or even for the governmental sectors, they have their own UAV team. And they can do the real, very formal surveying, or they can check, or they can get to know what is now for the traffic or for air pollution, or lots of things. So nowadays the UAV has been very widely used in Taiwan. If the UAV carry the NDVI camera, then it can create the NDVI feature, and NDVI feature will be able to calculate the bare land with a vegetation land, or the water without water, or we can get an NDVI feature and get to know what about the water stress, or some of the phenomena from the vegetation. So we can get to know the health of the trees, the health of the fruits. So there are lots of information we'll be able to identify, use this kind of NDVI information, and which is very easy to get nowadays. Like before, if we try to get an NDVI, we have to get like only the satellite image, or some other big airplane with a near infrared or some other infrared equipment. But now we can just use a UAV carry the NDVI camera, and that's it. And we're able to identify lots of things. Even for the thermal one, we'll be able to create the ground temperature, the real ground temperature. Once we can create a real ground temperature, we can get to know what's the urban heat index. Lots of study about urban heat island phenomenon. The urban heat, because of the building, because of the air conditioning, because of the cars on the road, because of lots of things. So there are people concerned about the urban heat island. And we often mention about this one, but use the UAV carry the thermal images camera. It can identify the exact location at the exact time, which means the spatial and the temporal one. Get all the information about the real temperatures. Then we'll be able to get to know if that really because of the urban heat island or is not, or where are the hot zones. And if we try to reduce the urban heat island impact, how can we do to reduce that? How can we make another wind channel inside the city? For example, like this one. This is our high-rise building inside the Taichung city government. So there are scientists, they use the UAV carry the thermal images and try to capture all the images information about all the road temperature during different time scale in the daytime and the nighttime, because they try to see if there is any way to reduce the urban heat island for the entire area. If we need to plant more trees, or we can have some other ways. If we open another water irrigation channel through here, will it reduce the city temperatures or not? So the city planner will be able to get to know what we can do for this area to reduce the urban heat island. But this requires a real information. You'll be able to identify in different time scale, in different spatial area. Without the UAV carry the thermal images nowadays, before we can only capture or get the ground temperature at this one or at that, we'll not be able to get the entire area information. But now we can get entire area information in real time. So we can really get a figure, get a number, and get the real data. So the GIS, the advantage of the GIS is combining together with those kind of good sensor, good technology, we'll be able to get the real information directly about our environment. So now we talk about the ESG, we talk about the SDGs. Those important figures we are talking today, we need lots of information, we need lots of data set to prove that. Also to identify where's the problem. Because without the data sets, you can only plan the things just like a blind person. With the data, with the real information, with the Internet of Things, with a good communication, with a good integration, with a good interoperability, you'll be very easy, very simple to capture all information directly. So like this is another example of how we can use a very high accurate orthophotos captured by the UAV and how we can identify the land waste monitoring in the coastal area. Like in Taiwan, some of the coastal area, we would like to know where are the waste and what kind of waste. Is it rubbish or driftwood or vegetation? Lots of driftwood is from other country, in Taiwan. because they were through with the ocean tide. But lots of rubbish, sometimes from local, sometimes from abroad. And where's the vegetation? So use the UAV carry the thermal images detection camera. We'll be able to identify what about the coastal zone and what's the percentage of the coastal zone as being merged with the rubbish or the driftwood. What's the percentage of vegetation still exists in a coastal zone? So lots of things we can use the UAV to identify lots of things. We use the UAV and capture all the images, overlay with the cadastral maps. Then we'll be able to identify who owns the map, who owns the road, and what's the information about that. And we can get to know if there's some problem with that. So there are lots of information we'll be able to identify or can be captured by the UAV. So nowadays, this kind of information will be very easy to capture by the UAV, just like the entire city information. Like before, if we try to make a very good city building maps, we need a lot of information, we need a lot of effort. But now we can just use a UAV to fly around the area. And if we need to get information about the slope, about the aspect, about the bare land, about the vegetation, about land cover, about the land use, we still need to do a lot of energy and a lot of work. But now we can very easily just use a UAV to capture all the images, use the rest information, and identify all the information, just like the team value, and create some kind of orthophoto. Those kind of orthophoto will be able to let us to really create some of three-dimensional information. So that's the good advantage of the UAV. So even now in the world, there are lots of programming person. They're very familiar with one program called GeoJSON. So using the GeoJSON, lots of people can write the source code and share different kind of images between the UAV. So it can be autopiloted by the GeoJSON. So it's very easy now. So that's why there's so many UAV company nowadays, even in Taiwan, there's so many of them. Because all the coding system, all the controlling system, even for the chips, is much, much easier, much simple nowadays. Use the GeoJSON is much easier than before. Much, much easier. So there are lots of new innovation company. They try to use a UAV not to capture just the building or some of the roads information, but they are already in the show business. There are several hundreds of UAVs, there are thousands of UAVs described in the sky during different kind of orchestra, different kind of world game. Use a UAV as a show business. It's a big business now because it's very easy to use this kind of technology now to control the UAV. And for another example is using the UAV and carry the thermal images sensors, we'll be able to identify like the land just beside my campus. It's the same places, but use the different kind of camera information. We'll be able to identify about the air pollution problem. As we can see, if it's a black and white, if it's in the visible color, or it's in the invisible color. And we can see about the air pollution, where it came from, and what's the source of the air pollution. So now we're concerned about a PM 2.5 or PM 10. Use this kind of thermal camera. It can easily identify the concentration of the PM 2.5 or PM 10. Let's look at this one. This is the UAV carry the thermal image camera in the night, just surrounding my campus. So you can look at and use the Jello, the ULO. You only look once. The software, the open share software. You can very easy controlling the UAV and also have the image identify if it's a car, if it's a truck, if it's a motorcycle directly. So even in the night, you can have a UAV on the sky and identify how many cars on the road now, where it's going, and are there any kind of motorcycle around? Are there pedestrian around? And what's the traffic now? So it's very easy to capture all the information because you can use the GeoGS and you can use the ULO software. Most of those kind of software are already open sources. So for people, it's very easy. Once you get the knowledge of the GIS, you get a knowledge of the remote sensing information. You can create your own application by different sensors, by different spatial and temporal information. Depend on how you can very easily and wisely use those kind of data sets. Those data including spatial information, including the attribute information. And those kind of information is for you to use it, for you to make different kind of application. So there are so many kind of application nowadays. Use the UAV to create some kind of 3D, and also will be able to use a very common use, just like the Google Earth or some other software, commercialized software, the S3, the ArcGIS, the Skylink, or lots of Skyline, lots of different kind of commercialized software. And it's very easy to create this kind of information nowadays. Very easy to create, very easy to create. So there are lots of available tools, available software, available hardware. It's already there for anyone to use that to describe our environment. But you have to get to know how you can really describe, how you can really analyze our environment. Because you need to get if it's raster or if it's a vector or anything else. One of the information in Taiwan is because we have so many different kinds of data cubes, just like I mentioned today in previous lectures about there's so many satellite images, there's so many UAV information, there's so many vector information, so many different kind of maps, so many. It all represents the spatial information, the attribute information for all the environment. So are there any way to really use those kind of information? We need a very fast way, like before we use database. Now we use data cube. Because our data is spatially and temporally for every data. There are spatially and there are temporally information. So nowadays we use a technique as a data cube. So data cube is the way to use a lot of this kind of information into a cube. So once we say it's into a cube, we'll be able to identify, for example, we'll be able to use different time scale of the satellite and replace it in the same screen. So it can very easy access all those kind of information and identify lots of information. Because each image has its own database, has lots of trillions of bytes of the information. So nowadays, all the data sets are not only two-dimensional, but three-dimensional, but with a time series. So with the time series, we need to have the database one. So there are multi-dimension of the remote sensing images nowadays. It's not only dealing with only one satellite image or one aerial photo or one UAV images, but there are so many different kind of images. And we're used to see things on a three-dimensional scale. For example, you can use your app on your cell phone to identify where are those commercial flights. But what if you can look at the commercial flights with the real satellite image as a background? So you can see what the commercial flight is looking at from the sky. So this creates a very useful tool for lots of different kind of application use. Because once you receive the position of the commercial flight, which is published in the world, you'll be able to get what the flight will be able to see now. Use the previous satellite image or air photo, or even if you have a very good real-time information, then you'll be able to see a lot of things. So that creates a lot of powerful usage from the two-dimensional to three-dimensional things. So nowadays, the lots of governmental sector, they try to very, very smart use of the GIS technology with the big data. They will be able to create, just like this one, a dashboard. For example, the traffic department in the city level, the police department, and also the water department, they can all share their camera, because each of the department, they own hundreds or even thousands of cameras in the city. If they can really share with each other, and the camera will be able to identify if there's a traffic, if there is floods, if there anything happening, if there's a fire on the building, they can inform the other department. So everyone can have a good integration system and can have a very good interoperability. So that's a good management. That's also good ESG. So GIS can serve as a very, very good platform, even follow the SDGs. So I think I've been talking about the GIS, I've been talking about remote sensing as a very beginning courses of the GIS courses offered by the Taiwan Space Union. So this is the first lectures. I was talking about the GIS, about the vector information, about the raster information, about the spatial information, and about the attribute data, and how we can use the data cube, how we can use the UAV, how we can use the satellite image, how we use the aerial photo to identify the environment, to identify for where we live, and what's the surrounding area, and what's the problem. So all those kind of information can serve as a very basic information for us to let us to get understanding about our world. So I think that's a basic idea of the Taiwan Space Union. Try to offer this kind of free online courses to all of you who has interest in the GIS and remote sensing and also UAV and some other application. So thank you for your listening for the past almost 2 hours. And this is Tien-Yin Chou from Fengyang University in Taiwan. And next week, I'm going to start with a smart city application. And I'll use some more application demonstration to you to show how the GIS and remote sensing and the UAV and the geo data cube can use for a city as a smart city. Why we can say it's a smart city? How to make a city smart? how the city can follow the rule is a very good SDGs. There are 17 requirements of the SDGs, and everyone's talking about the ESG now. How we can prove it? How we can do the real good understanding of all those information? So that requires an open and sharing communication, cooperation across the industry and academy and government. So that's the goal of Taiwan Space Union. To get all of you a smiling curve. For example, university professor, we doing a lot of research. Some commercial company do a lot of marketing things. And from governmental and also from the private sector, do a lot of development. So if it's value-added services, then we can get a very good, intelligent way to provide lots of different services to whomever who needs different kind of services. So I think that's a basic goal of the Taiwan Space Union. And thank you for listening for the first 2 hours lectures regarding the GIS. Hopefully, you can get a rough idea of what GIS is, what remote sensing is, and what kind of things we can use to integrate those kind of systems together. So next week, I'm going to talk about a smart city. Hope to see you again online, and I think there's still some quiz after this. So I'll hand over my screen to my colleagues, and they will start sharing this one with you. So thank you again. This is Tien-Yin Chou from GIS Research Center in Fengyang University, representing the Taiwan Space Union. See you next week. Thank you.
Thank you very much, Professor Zhou, for your wonderful course. Thank you. And that's the end of today's course. Please fill the Google form and the 2 quiz. If you have any questions, you can leave it in the Google form or email it to me. I will pass your questions to Professor Zhou. Thank you all of your participation. See you next week.